Hey, good morning, sixth grade. Welcome back to science class. I know last week I bid my farewells and thought it was going to be our last week, but I learned afterwards that we were going to do one more week. So I'm super excited to be with you this morning, and I kind of feel like this one's a free one. Like we're done with school, you are done with your grades. Today is just about being curious and just sitting back and just learning for the sake of wanting to know more. When I left here last week, I was trying to decide, like, if I get one more time to talk to these kids, what do I want to talk about? I set up a Google form for my students and had them take a poll. I told them that they could choose between the Apollo missions, hurricanes, local ecology, or oceans, and then I gave them a line to fill in something else. And several students suggested things we need to know for 7th grade, animals that breathe in and out of water, COVID-19 and how it affects the body, and floods. But through all of this data, what really stood out to me is over 70 students replied, and over 50% of them were begging me to cover the Apollo missions. Of these suggestions over here are things we need for 7th grade and animals that breathe in and out of water, and really COVID-19 being a virus. All of that is life science that you will get to cover in 7th grade. So I'm going to leave that for the 7th grade teachers. And we're going to jump into the Apollo missions today. I really like this topic for a lot of reasons. I've been really blessed to have several opportunities throughout my career to explore different topics in space in Huntsville at NASA. When I was getting a certificate to be a NASA teacher leader, I've had the opportunity to sit around the table with some astronauts and people that had actually been to space and hear them tell their stories. I've kind of taken all these experiences and kind of tried to put these stories together for you. And really and truly, this is a great topic for us in the great state of Alabama because we went to the moon through the state of Alabama. The rockets that sent us to the moon were designed and built right here in Alabama, in Huntsville. And I also, before we kind of get started and get to the Apollos, I want us to kind of clarify a couple things. Guys, when we're talking about rocket science, when we're talking about going to space, this was a total new kind of flight. There were airplanes and helicopters, but airplanes and helicopters fly using the same principles. It's all about Bernoulli's theory and air moving across the wings or the propeller. A rocket is totally different. A rocket stands straight up and down and just muscles its way away from gravity. So the huge Saturn rockets that took us to the moon were designed and built here in Alabama. So a couple of things. First, I want to share something with you. Does anybody know what this is? Here, I'll give you some clues and open it up. It's got some pages. It's not a book. This is not a book. This is something that maybe only a few of y'all have ever really seen. It's a record. This is a live recording of the first steps of the moon. Recorded and printed in 1969. This was actually a Christmas gift that an aunt gave me for Christmas one time. It's getting harder and harder to find the equipment needed to play such things. But yeah, guys, this stuff plays sound. It plays music. In this case, it plays the astronauts walking on the moon. So this poses some interesting questions. My experience with 6th graders, when we start talking about the Apollo and we start talking about the fact that we went to the moon, and I guess because your generation is so young, like, it's something we've already done. Yeah, we've been to the moon, okay? So I kind of want to walk you back in time a little bit and hopefully kind of really put the impression on you why this was such a big deal and really why the entire space program was such a big deal. So a couple of questions I want you to be thinking about, like, what do you already know about the Apollo missions? There are some movies out there. Maybe you've watched some of the When We Left Earth from the NASA series that is on Discovery Ed. These are fantastic videos. If you are interested in space, I suggest you go find them and check them out. How many Apollo missions were there? How many times did we go to the moon? How many people have walked on the moon? So these are some things we're going to answer today. Before we can get to Apollo, though, I want to catch you up with some stuff that I've kind of already talked to my students about. before we can get to the Apollo, we kind of need to build some groundwork for how we got to Apollo. What was first? So, the Mercury 7, these guys were the first astronauts. Now, keep in mind that coming out, I want you to rely on some stuff you've learned in history for a minute. Coming out of World War II, there was a space race between the Soviets and the United States. Like, we wanted to dominate and be the world power in space. And time again, they kind of beat us. And the first time that they beat us was with Sputnik. They got their satellite into orbit before we did, and this kind of rocked our world. So that leads to the creation of NASA and the formation of the Mercury 7. Now, I want to share a kind of a cool story about this picture with you. These 7 guys, these guys were all either fighter pilots or test pilots. The top of their craft, a lot of them were World War II vets. In this picture, these guys were like the toughest of the tough. This was like the first prototype of the spacesuit. And this was like their first photograph together in the spacesuit. And what I was told by Ed Buckby, the author of Space Cowboys, which is another great book, that these guys were pretty upset here because they had not developed the space boot yet. If you look at their feet, they are totally wearing black military combat boots that are spray painted silver to match their suits. So the feet were not quite developed yet. And if you look at this, these back 3 guys were not giants of men. They're actually standing on a bench back there. So most of these, in Space Cowboys, most of these guys recall this picture as one that they don't really like to see floating around too much, not one of their favorites. So we kind of just talked about who these first 7 guys were. Alan Shepard, and this is listed up here in the order in which they went to space. Alan Shepard was the first American to go into space. And then Gus Grissom, and then John Glenn. Most of you have probably heard his name. John Glenn, one of the things that he did before he was even an astronaut, he broke the sound barrier. He traveled in an airplane faster than the speed of sound. And he was the first man to do that. Then Scott Carpenter, he was a test pilot, and get this, an aquanaut. He left being an astronaut, took a little sabbatical to go be an aquanaut for quite some time. And then Wally Schirra, Gordon Cooper, and Deke Slayton. Mercury 7. So these first 7 astronauts, we call the Mercury 7. This first program, there was only 1 astronaut in the capsule. And the first thing we're trying to do is just leave Earth and come back. So like the first 2 Mercury missions, from the time of liftoff to the time that they hit back into the ocean, were about 15 minutes. They just went out to space and came back. And then once we could do that, we would go a little bit further and go a little bit further. So for all of these Mercury flights, the first 2 were 15 minutes. And then the next 2 were 4 hours because they'd go in space and they would do a couple laps around the Earth. So they were in space for about 4 hours before landing. Then they pushed it up to 6 orbits, and really and truly so that they could test some of their engineering. Something else that I find pretty interesting is that these astronauts, they got a hand in not only like the beginnings of the space program, they were helping design the capsules. They were helping design the flight mechanisms. A lot of them had engineering backgrounds. So the 9-hour flights, they were going up there and really test flying and maneuvering the equipment. And then the final Mercury mission was 34 hours, and that was really to see how the human body did for a full day in microgravity, which is something similar to what we see on the space station, except for now we're pushing it to a year in microgravity. Oh, and also, let me back up. We're going to talk about mission patches today. I think that this is really, really fascinating. Every NASA mission has its own patch, and the astronauts get to design these patches. So each patch has like a story behind it. And in this one, it's got the 7 for the Mercury 7, and then this is actually the symbol for Mercury and as a planet in Greece, as well as the element. After Mercury, we move to Gemini. Gemini means twins. If you know anything about maybe constellations or Greek mythology, Castor and Pollux were twins. So we go from having one astronaut to now we have 2 astronauts in the capsule. 2 men will fly together. And really the main purpose of Gemini was to bridge the gap from what we did with Mercury to what we wanted to do with Apollo. So in 1962, President Kennedy speaks at Rice University. And I don't do a lot of this, guys. In my teaching, I very rarely read you a slide, but this one's a quote and it's worth hearing. So President Kennedy addresses Rice University and he says, "But if I were to say, my fellow citizens, that we shall send to the moon 240,000 miles away from the control station in Houston, a great giant rocket more than 300 feet tall, the length of a football field and made of new metal alloys, some of which have not even been invented, capable of standing heat and stresses several times more than have ever been experienced, fitted together with a precision better than the finest watch, carrying all of the equipment needed for propulsion, guidance, control, communications, food, and survival, on an untried mission to an unknown celestial body, and then return it safely to Earth, re-entering the atmosphere at speeds of over 25,000 miles per hour, causing heat about half the temperature of the sun, almost as hot as it is here today. To do all this and to do it right and to do it first before this decade is out, we must be bold." It was this proclamation that Kennedy that really catapulted us into the Apollo missions. So, each Apollo mission had 3 astronauts. They would fly 2 in anticipation of going to the moon and 1 that had to orbit the moon, the commander waiting to rendezvous back. The goal was, as you just heard Kennedy say, to land humans on the moon and bring them safely back to Earth. In total, there were 9 Apollo flights. 6 of them landed on the moon, allowing 12 men to walk on the moon. 2 orbited Earth just to test equipment. Apollo 7 and 9 did not actually go to the moon. It was more test flight stuff orbiting the Earth. And then Apollo 13, you may have seen the movie. If you haven't, fantastic movie on Apollo 13, that while it did return home safely, they did not get to land on the moon. So, in talking about Apollo, we've got to start with Apollo 1. Apollo 1 is our first space tragedy. And it didn't even happen in space. It happened in simulation. So, Virgil Grissom, who was Gus Grissom you saw for the original 7, Edward White and Roger Chaffee were the 3 astronauts. And they're in their capsule on Earth doing some simulation training, and a fire breaks out in the capsule. And there was a problem with the hatch door, and within a matter of minutes, all 3 astronauts had lost their life. This really rocked our space program. Human life is very important to all Americans, especially our government and NASA. And one of the reasons why all 3 Mercury and the Soviets kept beating us to space is because NASA paid such a close attention to detail and to safety. They always wanted to try one more safety mission before sending a human. However, on the flip side of this, we see a lot of innovation come out of this tragedy. For instance, this begins the idea of fire retardant materials. I'm talking about fabrics and materials and plastic type metals that will not catch fire. Well, not only is that good for those astronauts, but we see it all around the world as regular civilians. A couple of places may be like an airplane seat. If you get on an airplane, the fabric that is on that seat is not supposed to combust for 90 seconds. Like, you should be able to put a flame on it and it's not going to go into flames. It may melt, but it's not going to combust for like 90 seconds. We also see this in like infant pajamas, like babies that sleep in cribs. You may notice that their pajamas say that they're fire resistant. That way, if a tragedy happens in the home, the infant's clothes or bedding won't catch fire until somebody can get in there to rescue them. So we see a lot of innovation come out of what we learned out of Apollo 1. After Apollo 1, and you can see it, this happens in 1967, so I want to kind of timestamp this because I had a student tell me a couple years ago, use the phrase, something about way back in the 1900s. So as we kind of follow this story, I really want us to focus on timeline here. So Kennedy had his speech in 1962, and then in 1967 we have the disaster of Apollo 1. So the next flight is not till Apollo 8. Apollo 8 what lasted about a week, and I want you to notice in this mission patch it makes an 8, which clearly that's what the Apollo is, but there's some science here too, because this is what their flight plan was. They were going to fly and see for the first time the backside of the moon that we never see from Earth, and then come back. There's some science here about gravity. When we talked last week and the week before about the Earth and the moon's gravity, the reason that things orbit each other is a dynamic between two gravities. If it's just one, then that one object would pull it into it, but it doesn't. The sun doesn't pull all the planets into it. The Earth doesn't pull the moon into it. Those objects are locked in place because of their gravity. So in going to the moon, in order to orbit the moon, they have to be able to get there in just the right sweet spot. I heard one of the Apollo astronauts say that there are only 3 options in doing this. If you get too close to the moon, you're going to crash on the moon. That's not a good result. If you get too far away, you won't get pulled into orbit and you'll go out into space. So like out of these 3 options, only one of them is viable, and that's to get it in that exact sweet spot, and there's a lot of math and a lot of science to make sure that they're in that spot. So this represents their flight path as well as their number. I'm going to pick things up a little bit. Apollo 9 didn't go to the moon, so we're going to kind of skip over him for just a minute. Apollo 10, I want to talk about this one really quick because Apollo 11 is the first time we walked on the moon. This is May in 1969. We already knew that in July we were going to have Apollo 11 where we planned to walk on the moon, and those astronauts were already chosen, and it was a huge media event. This was like the dress rehearsal. This was like the one trip before just to make sure everything goes right. But these astronauts were told that they could not land on the moon. They were going to do everything else except land. They were going to separate. They were going to rendezvous. They were going to do all the stuff that Apollo 11 was going to do, minus landing on the moon. In fact, I'm told that the engineers were so scared that these guys were going to do it anyway. Because astronauts were bold, they were brave, they were courageous, they took chances, and rumor was they were going to land anyway. So I was told that those astronauts were told they weren't getting any fuel in the lander. That the lander would only have ping pong balls to make up for the weight, and that it would not have fuel. That if they took the lander to the moon, they would not be able to get off the moon. So when they designed their patch, one of the largest things besides the 10 is this flame from the lander, which it didn't have any fuel in it. So this was like their little jab back at the front office for not having fuel to make sure that they would not land. This brings us to Apollo 11. This is the big one, guys. This is the Eagle has landed. They walked on the moon. Neil Armstrong, Michael Collins, Buzz Aldrin. I want you to notice something about this patch. This was the first and one of only a few NASA patches that doesn't include the astronauts' names. The first time that these astronauts submitted this patch, it was sent back and they were told to put their names on it. And these 3 American astronauts refused to put their name on the patch. They said that this mission was bigger than the 3 of them, that this mission was for all Americans, and so they did not want their names on the patch. So this was July 1969. Kennedy declared that he wanted us to get to the moon by the end of the decade, and finally, as Americans, we did it. We got to the moon, we landed on the moon. Now, I want to point something out here. In all of these missions to the moon, I told you the Apollo missions have 3 astronauts. Only 2 of them get to land on the moon. The lunar module has multiple pieces. So when they get to the moon and they get in orbit around the moon, the lander separates. And the lunar lander goes down to the moon and takes with it the 2 astronauts that get to walk on the moon. The commander has to stay in orbit around the moon. He doesn't get to land. He orbits while they're doing their work on the moon so that when they leave the moon, the commander has to be able to rendezvous back up with them so that then they all come home safely. So 3 astronauts, but only 2 get to walk on the moon. Apollo 12 was the next time that we went and walked to the moon in November of 1969, just a couple of months later. Apollo 13 is the one where there was some disaster, some malfunction. This is a really, really incredible story that I typically spend an entire day just talking about this with my kids, mainly because of the marvel of engineering and innovative thinking and the ability to look at these constraints and say, this is all I've got and I have to fabricate a solution, and the ability to do so. It says a lot about human spirit, but I'm getting short on time, so we're going to kind of push through these. Apollo 14, Alan Shepard was the commander of this mission, and you should remember him from the Mercury 7. So he was one of the original astronauts, and he also got to go to the moon. Which I'll also say, this right here in this patch, that's the gold astronaut symbol. This was the first patch that they included the gold bars, like when you become an astronaut, you're pinned with these gold bars. And this is the first patch where they use those gold bars. We see that we see it more in later patches. Apollo 15. Apollo 15 is one of my favorite missions because this is the first mission where they decided, let's film a science experiment. And they did. So it's, and you can, if you Google that hammer and feather science experiment, you can watch it, the actual footage from the moon where he drops a feather and a hammer to see if they're going to land at the same time with no air friction. So great little video. Apollo 15 is also where we first see the Lunar Buggy. This is a big deal because think about those guys in the huge spacesuits, how hard it is to maneuver and how much distance they could cover on each mission. With a Lunar Buggy, now they could drive around the moon and they could explore farther. So the Lunar Buggy was also a major feat of engineering. This picture of this gentleman right here, his name is Skeet. I met him at one of my trips to NASA. He gave us a personal tour around the museum. He worked on the engineering team that designed the Lunar Buggy. He was one of the original people who designed and built this. And what he's holding up right there is his lunar rover driver's license. It's hard for you to see, and there's kind of a glare on it, but it said on there that there were only 32 of those issues, like his driver's license to be able to drive the lunar rover. So Apollo 16 is going back with the lunar rover and being able to explore new terrain. From 14, 15 to 16, we're landing in different spots on the moon so that we can gather information from different places. The 16 stars around this patch represent the number of the mission. And then Apollo 17 is the final mission. It's the first mission to include a geologist. Like, we wanted to study the rock. We brought back tons of rock from the moon. And this mission traveled the greatest distance. It covered the greatest distance on the moon. So that was the final Apollo mission in 1972. We haven't been back since then. When I posed the question to some people at NASA about why did we quit going, the answer I received was because we had done everything we needed humans to do. That anything else that needed to be done with the moon, robotics had come such a far way that it could be done robotically, and NASA always prefers to send a machine over a human because of safety and monetary issues. So just very quickly, Mission Patch Handbook. This can be found on Amazon. It tells the story of a lot of these mission patches. If you're interested in that, The Real Cowboys by Ed Buckby. I want to tell you guys to enjoy your summer. I hope that you enjoyed today's lesson. I hope that you're curious and you can get on Discovery Ed and search NASA When We Left Earth, and you will find hours of fantastic, interesting information about not only the Apollos, but the space shuttles. So I hope to see you guys real soon. Bye, guys.